Hi all, so today I'm going to be showing off a project I've been working on for a couple of months now. This is a real mode operating system that I wrote from scratch. This is a true 16-bit, would run on really ancient machines type deal. It's called PegasOS, as you can see the Pegasus logo. And here we're booting. This is actually booting off a 3.5-inch floppy. And here you can see that it's come up, and this machine has 2 floppy drives, and it has a serial port with 2 actual COM ports on it. And we've mounted the file system, the FAT file system, on the floppy, which has a shell, and we've loaded the shell. And we're actually going to show, so this is the monitor off of the machine that we booted. But I want to show you that this is a real preemptive multitasking scheduled system. Even though there's no memory protection to protect processes from each other, it is still true multitasking. So we have a process going on over here on the console, and this is actually a serial terminal. We're running a shell on the serial terminal, and the shell is actually complete enough that we can run hello world. And this is actually making syscalls into the kernel here, and you can see hello world, and then 1 second has passed because it's got a wait and a sleep syscall. And so what's going on here is we actually loaded a program called hello off of the floppy, ran it, and then returned back to the shell. And over here on the console, you can see we've got some debugging information that told us that, hey, I loaded hello, here's the, this is just pointers to the kernel data structures that represent the process. And we also even have, let me get around here to the other keyboard, we have a hotkey. We even have a little kernel debugger here. You can see here we've got a register dump, we've got a disassembly. We can sit here and we can pull up the list of all the tasks that are running in the system. You can see there's quite a few, because there's a task for every possible interrupt that could happen. There's an idle task. There's a couple of tasks running. There's the shell, obviously, and you can see B71E there. I mean, that is a zombie at this point, but that was the hello world task that we ran, and then down below is just like all the task free list. Can set breakpoints, can single step. So yeah, I'm pretty happy that I was able to do this. This is all written actually with a old school compiler. This is written using Microsoft's compiler from back in the day, version 8 of their C compiler, which was, I believe, is the last version that could actually produce 16-bit code. So yeah, this is ground up all the way from hand writing the boot sector to writing the kernel and to writing the shell to writing C library. So yeah, hope you like it. I'm probably going to put the source up on GitHub if anybody is interested in seeing it.